So it says to rewrite in logarithmic form. So we're going to rewrite these, just kind of get in that habit of being able to switch things around. Remember, the base of the original one becomes the base in the log. So log base x of y would equal 3. And the exponent is what it ends up equaling. And then again, we can rearrange the next one. Log base 5 of 125 would equal x. So being comfortable moving those around and kind of switching them back and forth as needed. The next one I wanted you guys to factor, and this probably feels like it's coming out of the blue, but being able to factor this way is going to be helpful in what we're doing in some of these log problems as well. Do you guys remember how to factor like this?
Yes.
So this is the one where it's going to be two sets of parentheses. We know the first part of the parenthesis is what? X. Because x times x gives me x squared. And what's the rule for the second half? Add to what? Yeah, add. Multiply here. So add to negative 6, multiply to give us negative 16. Usually finding the multiples is easier because adding is kind of unlimited. So multiply, I think about 1 and 16, that doesn't give me 6. 2 and 8 does. So it's a positive 2 and a negative 8. The reason it has to be those signs is because we want to get that negative 6. Now if you have it flipped, the negative 8 plus 2 is fine as well. And that's something you guys did in Algebra 1, but then you also did in Algebra 2 probably a whole lot. So it's a good thing for us to review. We'll be using a little bit today. Okay? All right, so we're going to learn a few different laws of logarithms. Now the thing is, all of these laws, the way to memorize them is to relate them back to exponents. So if I'm so this first rule, I'm going to relate it back to multiplying with exponents. So I'll show you guys what I mean. So in terms of, guys, stop talking, please. Oops, not that, not add, not equals. So if I'm looking at this, and now this is one where you can't actually do it. I should probably maybe pick numbers you can use. But if I'm trying to explain to someone how to multiply x to the a power times x to the b power, what do you do with the exponents? You're going to add the exponents. So this would be a plus b. That's a rule we talk about, like if that was a to the second and a to the third, it'd be a to the fifth. That rule translates over to this. So, because exponents and logs kind of are like family, they're like each other. So we can take multiplication and we're going to break it up as addition. So this becomes, I do the log base b of u, so the first one, plus the log base b of b. So I go from a single log to 2 logs, multiplication becomes addition. Same thing happened here. I went from 2 bases to 1, multiplication becomes addition. So they link up together that way. The next one I'll show you guys is division. And you will get like a note card for this test, so all these different rules we have to know. You're going to end up being able to use a note card, but at the same time, understanding them does help. You don't have to necessarily memorize it. What are we going to do with the exponents in this case? We subtract them. So division becomes subtraction. So now, I will point out with subtraction, you have to be careful. Sometimes you're going to want to think about this as being a parentheses around here. So like if I can kind of if I could draw light parentheses, sometimes that's going to be important to point out because when I subtract something, if there's a lot more going on there, I have to make sure I use parentheses. So you might want to include that just as you guys work through this. The last one's probably the one that's kind of the strangest to try to make the connection, but it's still there. Is our exponent power to a power. So if I have x to the a and then to the b power, Do you remember what we do with the exponents? We multiply them. And this is where this one gets a little bit weird. They let you take, if this is a log to a power, you can take the power and you can drop it down in front and make it multiplication. So that s gets multiplied then to the log. So all of these rules, again, come from exponents. So it's not relearning a whole bunch of new rules. They kind of have that connection. So hopefully you can kind of help that, help you to make those, like kind of those links and that understanding. So we're going to rewrite some problems going one way or the other with this. So rewrite these using laws of logarithms. Now I'm going to tell you they're going to combine more than one rule in most of these. So you're looking for if there's multiple things happening. So like this first one, I can see that there's multiplication here and there's a power. Now the question is the power on both the x and y or just the y?
Y.
Just the y. So I would suggest breaking them up first because the power is not on the whole thing. So I don't want to drop this power in front. I'm going to break these up first. So multiplication becomes what? Addition. So I broke up my multiplication and made it addition. You okay with that? So the first times the second, so first plus the second. But there's one more thing here. This exponent, we can rewrite that. So I'm going to take this exponent and I'm going to drop it in front, but I only drop it in front of the log that it's attached to. And it becomes multiplication. You can just write it in the front. All right, so see if you guys can try the second one. See if you can figure out what you need to do there. If you want to wait for us to all do it together, it's fine, but I'll give you just a minute to look at that and take attendance quick. People are all escaping here. So, what'd you separate first? Did you do the power or the division?
Division.
Division, I agree with that. The reason we want to use the division first is the power is only on the x squared, it's not on the y. So you want to separate those out first. So we break it up as subtraction, and then again that power is just going to drop down in front. Now again, if you want to put parentheses on the second half because it's subtraction, you can. You don't have to in this case. The next one we're going to want parentheses. And this next one's kind of a big, ugly one. So if you worked ahead at all, I'm probably going to have to write small for this one. Probably not going to fit otherwise. Okay. So again, I'm going to separate out the division first. So in this case, I am going to put parentheses because there's kind of a lot going on with that subtraction. So all of that's in there needs to stay inside the parentheses because otherwise I'll somehow lose this negative. It's going to get confusing otherwise. So on the top, or the first part, I'm going to drop that in front. And then in this parentheses, what am I going to break up? The 4, but I have to do something else before that. Do you see it?
Separate the two into a log.
Yeah, we have to break that up, the multiplication. So that 2 is just a separate log. So we're going to break those 2 up first. And this one, since it's multiplication, becomes addition, which again is kind of weird because technically this isn't a parenthesis with the subtraction, so we want to be careful about that. So again, this ends up being big and ugly at the end. This 4 is just going to drop down in the front, but if you take it step by step, it's not too bad, says the math teacher. So when in doubt, I would use parentheses, just to be safe. It kind of helps, especially if there's multiple parts. Now you may be asking yourself, why would we ever want to do this? The reason is sometimes when we spread things out, things will cancel. When we spread things out, we'll be able to figure out what this is, and we'll be able to figure out what that is separately. Sometimes all together, they don't make a ton of sense. So moving them apart and taking them apart and putting them back together is just us practicing. It's like exercising or warming up before we actually do a little bit more with this. So these want us to evaluate them. Again, that basically means we want an answer. So when it says evaluate, it means I want to answer what I've done. So find the answer. So this does not mean just simplify. Try to find the answer if at all possible. That's probably a clue that there's going to be an answer. So in this first case, we know we can drop this power down, right? Now, one of the things I want you guys to think about, I'm going to show you guys how to put log base 2 of 8 in your calculator if you don't know how already, but I do want to just show you guys that we can do this by hand. What I would love to see, if you guys remember, is I love it when the base matches the thing I'm taking the log of, because remember that all cancels if that's the case, or it leaves it to the power. So what I want to do is I want to rewrite this base of 18 with a 2 instead. So again, this is kind of a little bit of an advanced maneuver here. 2 to what power is 8? 2 to what power? Yeah, what is it?
4.
I thought I heard it. 2 to the 4th? Check it. It's the 3rd. I thought I heard it. So yeah, 2 to the 3rd is 8. So what we can do here is now this power can drop in front with that one. So I'm left with 2 times 3 in front. But what happens with log base 2 of 2? It cancels. This goes away. So I end up with 2 times 3, which would just be 6. So this would get to cancel then. So when we can get those powers to match, it's really, really awesome, and it works really nicely for us. Again, I'm going to show you guys in a little bit how to do a little bit more of this on your calculator to kind of get you guys thinking about this. This next one here, I see that H's already match. But rather than having a root, I would prefer an exponent, because exponents I know I can drop in front. How do I rewrite this? Very good. So remember, and this is something we talked about at the start of the logs, is h to the 1/3 is the same thing as the cube root of h. And we learned last class, or maybe a few classes ago, that basically all these cancel and I'm just left with a 1/3. So if I can rewrite this in a way that has that base matching, that's really, really helpful to me. Okay? All right, so I want to show you guys, this is called the change of base theorem. If you have an older calculator, or maybe like you use one of the scientific calculators we have in here, you might have to do this. Some of you guys have found that your calculator, yeah, go ahead, just don't step on their painting. you might have already found this in your calculator. I think most of your calculators have this in the math menu. If you kind of like scroll down, there's like a base, I think it says log base or something like that. If it doesn't, there's a way to do this without that in your calculator. Or if, like, let's say you're at home and you're using your cell phone as an option to do this. You can take the log of x, just the regular log that's in your calculator, divided by the log of y. So let me show you guys an example that we can try and make sure we see what it looks like. So log base 5 of 125. FYI, this should equal 3, because 5 to the third power equals 125. So if you have not yet found this in your calculator, take a minute to find this. If you don't think you have it, I can check for you, I think. I don't know all the tricks of all the calculators. Otherwise, if your calculator seems like it's not very smart, you can do this instead. So like the calculator on my screen up here doesn't know how to do like fancy things like that. Like I would have to, there's log down here. So I would have to do 125 log divided by 5 log, and there's my 3. So I have to do it like kind of a clunky way. Some of your calculators will just do it. Did you find it in yours or no? Did you just do it the way?
I have a program.
Oh, nice. So you may have a program if you're Jacob. You found it in yours, right, Rebecca? Yeah. Is it in yours or just? Yeah.
This one,
Did you find it?
6, but then
I've just been doing it the old fashioned way to start out.
this one I can't get any credit. This equation.
I think it's easier to use the regular.
Well, I can just type everything in here, so I just type whatever base and whatever.
I'll just use the previous answer then type it in.
So yeah, you can, you figure it out? Yeah, you're good, okay. So log base 5 of 125.
So
Wait.
I can do it, but it's kind of like this one because it's literally just what matters.
Yeah.
Things done. Like on the last one.
That's weird.
And then I tried changing it. Freeze.
Yeah, that shouldn't impact it, but yeah, that's really weird. 'Cause did you guys, can I steal? I don't think yours does, I think you have to do it this way. Hey, let me steal, can I steal yours for a second? I just wanna make sure that this one does it correctly. And then, I wonder if you need parentheses around it, like bigger, let's try that.
I thought I had it on my side.
Yeah.
Wait, let me see.
So like try, oh wait, 39 there, what did I do wrong? Maybe-
This one. What the?
I might be doing something wrong and I can't figure it out. I think it, why would it have to be 9? So it'd be 3 to the second. Now that I think about it, I think it should be 9. We might have to come back to that one. So ignore my answer for letter 2A. We might have to talk about that. So you might have to do it the long way. So we do log 125 and then
I'm
divide
getting
by,
6 for my calculator.
you know. You got 6 for,
2A.
okay, yeah, I might have to look at it.
It's not 6, so
Yeah, it is not.
it's like 1.
For 2A. Put it in our front.
No, she's looking on the front side. Yeah, sorry.
Oh.
We'll figure it out. I'll look back at it. All right, is everyone able to get, somehow they got 3, right? We're okay? All right. So, however you guys go about this, we're trying to do these, like whatever it happens to be. I'll kind of put, these are all kind of crazy decimals here. So this one I got like 1.43. If you do it this way. 1/3 would be negative
What would be the
0.3.
right way to put it? When you do it in the parentheses, it says when you
That's
balance
true,
it
yeah,
out.
I have to check on it, I'll have to find out. That is weird, I don't know, I'll have to find out more. I'll do it. Yeah, I'm glad that those are, yeah, I'll have to check on it. Sometimes I don't think my best standing in front of 10 humans who need my, my brain. That's probably not a great thing. All right, so let's finish up with a few more of these here, so stick with me here. Did you guys all get these to work? Negative 1/3, negative 0.3 repeating, yes, we're okay with that. All right, so these next couple, we're gonna kind of show how we can solve for x. We've done this a little bit already. If you're ever struggling to do this, sometimes just changing it to exponential form is easier. Because if you try to put that in your calculator will be confused. So a lot of times, changing to exponential form, if I could spell exponential. It can be helpful. It might make it easier to solve if you can't solve it the way it is. Sometimes moving things around and kind of changing it around. So my base here would become 3. My power would become 6. So in order to figure out what x is, once I write it that way, that just looks like a pretty easy thing. It's going to be, pretty like our large number, large-ish. But that's a lot easier to solve than the other way, right? What is it, 729?
Yeah.
Yeah. So try exponential form if you're stuck. Same thing for the next one. Now this next one's going to require a little bit more thinking once you rewrite it. So again, my base, we have x in this case. My power becomes 4. Do you guys remember how to solve something with the 4th power?
Yeah, you should limit it to the.
Yeah, the 4th root. Yep, it's just, yeah. Not really the most mathematical way to say it. Yeah, we're going to use the 4th root. We're going to use the 4th root of 81. It's okay. No judgment. I'm all good.
It's okay.
4th root of 81. And what do we get for that?
3.
We should get 3. Are you guys all finding the 4th root on your calculator? Bless you. Your calculator should be able to do the 4th root. Okay?
Well, because that's
So you have to use the math menu. And then you have to use that one. But I think you have to hit a 4 before it. So go backwards, so clear out. So hit 4, and then the math, and then that little thing. It's going to assume that's what root you want. And then now 81. Should work. There we go. And just kind of getting in the habit of that to find it. Yeah. Okay. All right. So our next one here, you guys. This one we have to look at. This one right now is 2 logs. We prefer to not have 2 logs. So we're going to put the logs together. So we're kind of doing the opposite of what we did on the other side. So we're going to join these logs as one. It's like a marriage of logs. So they become a single logarithm. Do you guys remember what we do with those 2? Addition becomes, it becomes multiplication. Okay. Now it's a single logarithm. It's kind of a complicated one. We'll deal with that in a second. And this is something you probably maybe haven't seen before, so just kind of hang with me here. So at this point, now that we have a single logarithm, now I'm going to suggest turning it over to exponential form. My base is 4. My exponent is 2. Well, that's just 16. Not a bad number to work with. What I have here is I could FOIL that through. I could distribute it through. We eventually are going to anyway. I'm just going to rewrite it the way it is right now just so you don't freak out on me if I'm doing too much at once. So now this becomes an algebra problem, back from algebra 1, algebra 2. Okay, so in order to solve something like this, we need it, and hopefully this kind of reminds you a little bit of our warm-up. It actually is the exact same question from our warm-up. We need to move that 16 over. We have to use what we call the zero product property. That's where everything always equals 0. So we have to move that 16 over. So again, this is algebra review, and it's okay if it feels a little bit like, oh, it's been a while, because it's been a while. But that's why we do the warm-up sometimes that we do. We're factoring this now, but it factors very nicely and pretty easily. All of you guys seem pretty confident about that. So that -8, +2. And do you guys remember how we solved these? How do I solve it now? That's the, like, supposed to be the easiest part, but sometimes people just are stuck here. Remember? The zero product property says if I multiply two things together and it equals 0, either this one or this one has to equal 0. So we just set up two very simple equations that say each of these could equal 0. We can solve those, right? What is x here? 8. What's x here? -2. Okay. Now, eventually, we're going to end up throwing this answer out. And your book's going to eventually throw it out. We'll talk about that a little bit more in the next few days. But technically, you can't take a log of a negative. So eventually, we'll end up throwing that negative value out. But for right now, just kind of get used to solving. All right, last thing here, our rabbit population. Our rabbit population is growing. We have a formula that tells us about it growing. Do you guys remember our formula? It has the funny name. BERT. Okay, so we're going to use the BERT formula. He's got to come in at once when we yell BERT, but the BERT formula. It says a rabbit population has grown at a rate of 5% per year over the past 10 years. This is where we're going to use logs, like Jacob asked us about like a week ago. Hey, can't we use logs to solve this rather than guessing and checking our graph? Yes, now we're going to use logs. So we want to see this rabbit population grow at a rate of 5% per year over the past 10 years. That's what it's been doing. At this rate, how long will it take for the population to quadruple? So we want it to be quadrupled, which is 4 times its original size. Now, I'm actually going to tell you this 10, we actually don't want to use that. It's like kind of a scary, like, throw it in there just to confuse you number. They're just telling you that this has been happening. So the fact that that happened over the past 10 years, great, but like it's kind of like extra information to confuse you. So just a heads up on that. Our rate is 5%. Do you guys remember what we need to do that percentage?
0.05.
0.05. We want it to quadruple. We have no idea what our rabbits are right now. I don't know if we have 10 rabbits or we already have 500 rabbits. I don't know.
Rabbits like whippers.
Yeah, really fast. But we want to know how long, so like if we did have 20, how long would it take till we have 80? If we had, 100, how long would it take till we have 400? So we want the ending amount to be 4 times as big as the start. So we want this to equal 4. So I don't care what it starts with, I want it to end with 4 times as big. So, and we're trying to figure out how long that would take. So rather than guessing and checking, let's use our logarithms. Let's switch this base, or switch this to logs. So, log base E, what do we call that? Log base E? Natural log ln, yep, of 4 is going to equal the exponent. The good news is ln of 4 is a really easy thing that we can type into our calculator right now. So we got like 1.3863, something like that. Now, I don't know if you, I hope you guys do this. I don't retype that in, I just hit divide by 0.05. It's more exact than if you retype it in. So leaving that previous answer in there, if you haven't been doing that, please do. It's a little more accurate, and I get 27.7 years, so how many years would that actually be?
28.
We'd have to go to 28 years to get it to quadruple. Okay? Questions there? All right, good work. So, homework is listed there for you guys. Look quickly here.